Hi, my name is Keiko Harada. I'd like to talk about cost optimization with Windows containers. I thought it would be good to provide an overview of the containers first before we go through this. So as you can see on the left-hand side, there is a system that runs VMs with application and an isolation. When you look from a cost efficiency perspective, whole operating system needs to be spun up for even a simple app deployment. Large size makes it difficult to move images easily across environment. And also due to this, there's a high utilization of underlying resources. Whereas on the right-hand side, where the container system runs, containers enables you to pack a lot more application into a single physical server or a virtual machine. This is because containers share the operating system if you are utilizing the same operating system images, and you do not need to spin off operating system each time. It has a much smaller footprint than a virtual machine, and this is because containers are copy on write. In addition, with containers, you can create a portable, consistent operating environment for development and testing and deployment, and this is all because of the size. So when we look at the customers today, you'll see a situation where the customer would require to run multiple applications with different dependencies or versions while developing. You would need to deal with registry resettings and automating scaling and configuration. But with containers, you can make your application portable and reusable because they're inside a container. Since it is an isolated container, developer can control the dependencies and versions of application easier in a same environment. Also, using declarative config and control loop, you can automate the application easier with Kubernetes. So we just covered how a single container can help save costs. But what if I want to scale my application? What if I want to leverage modern application? As you're aware, modern application or microservices is an application that is a collection of loosely coupled services. It breaks down a traditional application into these components so you could easily modify or add fixes based upon your business needs, which monolithic application is not easily done. And the reason why is you need to go into the source code, change, and recompile the entire application, whereas for the microservices, all you have to do is change that simple component. So now, how do I do this? This is where Kubernetes comes in. Kubernetes is an open source platform which is part of the Cloud Native Compute Foundation, or CNCF. Kubernetes leverages containers and orchestrates containerized application. So if you want to run application in a scale or a group of containerized application with failover and load balancing, it can easily do so. And now with Kubernetes on Azure, you could easily onboard to a Kubernetes service without creating Kubernetes cluster on your own and manage them. Now, let me explain more about AKS, or Azure Kubernetes Service. AKS is a fully managed Kubernetes on Azure. It is an enterprise-grade platform due to the following. Built-in best practice with Azure Advisor and Azure Portal by providing actionable recommendations based on extensive engineering knowledge. Also, multi-layer security with Azure Security Center to harden security in layers of isolation across compute, data, and network resources. We have enterprise support with Kubernetes experts and interactive portal diagnostic and troubleshooting experiences. And lastly, consistent configuration and governance with unified management. Now that you've modernized your application, how does an end-to-end development lifecycle look like? So this is an entire diagram that shows you. On the left-hand side, the existing application can be containerized through lift and shift and put it into containers, or either you carve them and make them into a smaller component such as microservices, and create an image and store them into the container registry. From there, you can pull your image anytime and reuse them. And you can do that through a CI/CD pipeline with Azure DevOps or GitHub and deploy them into an AKS cluster. So to summarize all this, Windows containers have a much smaller footprint than virtual machine because of the cloud on write that it can actually do. You will save on spending with isolation between applications if you have multiple different versions. Also, you could run multiple different versions and instances of the same application on a single machine, even though their dependencies, you might have a same dependency but different versions. And also lastly, AKS will help you optimize running Windows modern applications with consistency.